Okay, so now the next topic is now do the what we set out. We said that it doesn't have to be defined over minus pi to pi. This is just part of your base basic case. But we can generalize that like x is from minus L to L or 0 to 2L to L. Or if you don't like 2L, you can even do 0 to L or whatever you want, right? And so if we choose this, and we just need to figure out what we need to do to all these formulas, right? Basically, you want to be define your variable so that this x, like you call that x prime, you call this all this x prime, x prime, x prime. But so x prime, x is defined from minus L to L, but you want x prime go back to this base case, minus pi to pi, right? So x must be proportional to x prime. You just want to figure out the proportionality constant. So when x equals to L, x prime must equals to pi. So you can say that x prime must be pi, it must proportional to x. But when x equals to L equals to pi, x prime goes to pi. Divided by L. Right. So that's what you do, or inverse. The inverse relation is x is L over pi x prime. Right. So if you want a formula for using x instead of x prime, remember we changed all this to x prime, right? Because now x prime is what is the first case. X prime is from minus pi to minus pi to pi. Like that's our first case, but we want to use x is the x prime, so we define this x now is L times x prime over pi, or x prime is pi x over L, right? If you want to use either one of them, so like using this instead of x prime, you have n pi x to L, right? So that's not too bad. We just need to a little figure out. So n pi x over L, pi x over L, change all that back to x. Okay, then you get your expansion. Now the next thing is the formula for the coefficient. It should be the same because if we use x prime, then our formula is correct, right? But now we want to use x instead. So we need to do a change of variable. So x prime is pi x. So for this function, doesn't matter. You just change it. Either function x prime or x doesn't matter. And for this, you change it to n pi x equal L. Then x pi is pi. You have a pi, or put the pi here, and divided by L. So pi and pi cancel. 1 over 2L. Okay. And likewise, you can change the sine and cosine formula this way. Right? Yeah. Yeah.
So when you have
Yeah. Yeah, we want to x is what the original. So you're given a function that is defined from minus L to L. You want to do a Fourier series expansion over that function over this domain. Okay, but the original formula require that x is from minus pi to pi, right? Or 0 to 2 pi, doesn't matter, because they are assumed to be periodic. After you do the expansion, is periodic, right? So what we need to figure out is how to scale back to that case. I mean, that case is just this formula with all before I change everything. is an INX prime, right? We call the originate INX, but in order that as you can use the formula, I require that the INX prime and X prime is defined on the domain minus pi. That how we can use that. But now we just figure out what the relationship between X prime and X prime, or how we scale X such that the X prime would be defined on minus pi to pi. And to figure that out, is using this formula because X has to be proportional X prime. And we need to figure out the proportionality constant. And the second condition is when X is L, then X prime must be pi. So you basically multiply by pi divided by L. So that when X equals L, you cancel the L, that becomes pi. And likewise, X equals minus pi, and minus L, cancel this, you get minus pi. So basically, whatever the X prime here, you use this formula and substitute this to pi X over L. That becomes okay. So I mean, this what I'm showing you is how you rescale it, so that you don't need to remember another set of formulas. You can figure that out, right? If you forget about this new formula, just the base formula, remember this formula for the 2 pi period, then you can use this rescaling to figure out all the formula later. The general formula. Is that okay? I mean, if you memorize that, it's also fine. You remember this set of formula, then to go back to the base formula, you just say pi, L equals to pi. You set L equals pi, you cancel the pi, this becomes 1 over 2 pi, this becomes INX. So you can check that your new formula is correct by just choosing your period L exactly as pi. Right? Then you recover the old formula by your new formula. Is that okay? Yeah.
But the integration didn't change because
Yeah, the integration changed. Yeah, it's not changed the minus L. Obviously, when you change the variable, you obviously need to change the limit. Is that okay?